Hi, I'm Dr. Kristen Roboski in the Physics and Astronomy Department. I'm a materials scientist, and I'm going to be explaining our sputtering system here today. We make thin film materials in this tool. Just to give you an idea of what that means, the human hair is about 50,000 times thinner than a meter, and we routinely make materials that are 100 to 1,000 times thinner than the human hair, and we call these thin film materials, and we'll be making this in our sputtering system today. So this chamber forms a vacuum system that we take all of the air out of this tool. So you notice there's this kind of black circle here. That's really a gasket that helps seal the system up so when we turn on the vacuum pumps, all the air can get taken out. Inside this chamber, you'll notice three different sources in here. Right now they have little doors over the top, but these are three different types of materials. Right now we have silicon dioxide, aluminum, and titanium loaded. Depending on how we set up the system, we can make any of these types of materials onto our substrate, which I'm going to load here in just a second. This is a fancy oven with a lot of buttons that we can push. First, we evacuate all the air, then we put an inert gas on the inside. We're going to be using argon today. And then we choose which of the sources we want to use. We actually have a heater up here that we won't be using today, but we could use if we wanted to. And we load our substrate in. So we can basically play with pressure, temperature, and then as well as the power of the tool. Okay, so now I'm going to actually load our what we call substrate, which is what we deposited on, into the chamber, and I'm going to load it on top of the substrate heater. Today I'm going to be depositing on the microscope slide. Since we're just doing an example film today, you'll notice the black Sharpie dot, which is useful because after we deposit, I can remove the Sharpie and actually measure how thick of a film we've deposited. All right, so if we come around here, and we will load this on. I have to twist in the back here so that way it actually locks into place. And then we have a loaded sample and we're ready to close up our system and start evacuating the air. All right, so now our sample is loaded and ready to go. We can go ahead and close the chamber up so that way we can evacuate out all of the air, so that way we can start our deposit. All right, so I'm going to put my hand under here in case the substrate holder is not well locked into place, so I can catch it on its way down. Oh, it looks like we're good. So now I'll go ahead and close up the chamber. We have this little knob that we come up here and we can tighten down. You always want to do this at atmosphere and not when we are at vacuum. And then we want to check our valve here that is fully closed off because this lets air into our system to vent. And now we are ready to start pulling the air out with our vacuum pumps. All right, so now our chamber is closed up. We're ready to start pulling the air out of our vacuum chamber. But first, I just want to introduce you to some of our controllers. This is our substrate heater controller, so those lamps on the back side of what we actually loaded into the chamber, we could control that from here. This is a high vacuum system. So we have two different types of vacuums, a mechanical pump to bring us the first step of the way in how much air we can pull out, and then a turbo pump that takes us the rest of the way. That means we have to use three different types of gauges to get to the different levels of how much, what pressure we are at. And we do that with this. And right now we're on this gauge in the middle here that tells us that we're sitting at atmospheric pressure. This controller right here controls the gate valve to the big silver vacuum chamber we just loaded. And so it controls the valve system that determines what pressure the system is at. So really in the next few minutes, we'll turn on the vacuum pumps and these will change as necessary to get our system to the right pressure. All right, so now I am going to open the gate valve, which you can hear on our chamber, and I am going to turn on the vacuum pumps. And now we wait. All right, so now we've been evacuating our chamber, and we are going to turn on our ion gauge, which is the lowest level gauge that we have and has to get to a certain pressure before it will even turn on. All right, so we are down to just at the 10 to the minus 6 torr level, which is exactly where we want to be to get started. I also need to move our gate valve controller to remote mode so that way it talks to the computer, which is what I've just done. And I notice it is now closed on the computer, so I'm going to go ahead and open it back up so that way it continues pumping down. All right, I'll turn my sensor back on since it turned itself off. All right, and now we are ready to start depositing a film. Okay, so now we're down at the right pressure. We've evacuated enough air from our vacuum system. I've turned on an argon bottle so that way when we put gas back in, it'll be inert. And we have 2 sets of power supplies that we use to potentially run this tool. We have RF power supplies here, 1 and 2, and a DC power supply here. Depending upon the type of material you want to deposit will determine which supply you're going to be using. Today, because we're going to do this demonstration with an aluminum source in our chamber, I'm going to use the DC power supply down here. So now I can go ahead and turn on that power supply. Okay, so the gas bottle that we've used for our argon is here. When we came in, I mentioned that you had to turn on the gas. We turn it on here, and then otherwise everything is ready to go, and the computer will drive the actual gas flow. When we're done for the day, we want to make sure we close this valve again so that way we don't accidentally run our gas bottle of argon dry. All right, so now we're going to come over to our software that remotely drives all of the equipment on the tool and to deposit a film. I mentioned earlier that this is basically a very fancy oven, except now we can adjust more than just temperature, we can adjust pressure, and we can adjust power. So the first thing we're going to do is we are going to turn on our gas flow, which you just heard a valve come on in the background that's allowing our gas to flow from our argon bottle. Then what we're going to do is we're going to set a pressure inside the chamber for us to strike a plasma, excite the argon gas in the system. So I'm going to set a pressure at 35 millitorr. And the noise that you hear in that background is the gate valve opening and closing a bit to adjust the pressure in the chamber. Then what I'm going to do is I'm going to set the power set point to strike a plasma on our aluminum target. Okay, then I'm going to turn it on. And right now, the door on top of the aluminum target is closed. You'll see a little tiny bright dot that shows that the plasma is on. This is what we use to create the layers in a recipe, is we would choose a strike file down from here, and then we would choose the appropriate deposit or coding file that we made, create our recipe, and move on. For today's example, I'll go ahead and pull something we've already made, and this has both that strike file and our deposition file. So now the computer is doing everything that I originally did. You can hear everything trying to achieve its pressure. We should have a plasma now inside the chamber. And the system starts to ramp up to the appropriate power set point for the deposit, and that's what it's doing right now. So right now we're waiting for our shutter to open, and so we're doing kind of a pre-clean of the source, so that way anything that might have accumulated on top that we didn't want to be there as it sat around and not being used gets kicked off of the source. Once the shutter opens, then you are actively depositing the aluminum on that glass side substrate. And you'll see a nice, pretty colored plasma, probably in the pinkish to purplish range, that occurs as the aluminum is depositing on that aluminum sample. This is going to be about a 20 nanometer film. We know the deposition time that it takes, so you can calculate how much thickness you expect for aluminum. And that was the sound of the shutter opening, and you can see the plasma inside the chamber now. This will now run for about 3 minutes of a deposit. Once it's done, the tool will ramp down the power so that way we can safely turn off the power supply, and our deposition will be done. At that point, we can turn off our vacuum pumps, let the whole tool come up to atmosphere, and then we can take out our sample and see what it was that we made. All right, so our computer just came up with a little interface that said process is complete. I clicked OK on the button, so now we're okay to shut down our DC power supply because we won't be using it, and we can go ahead and turn off our vacuum pumps. This is going to allow our system to come up to atmospheric pressure over about 12 minutes or so, and then we'll be able to remove our sample and see what it was that we deposited today with the aluminum. All right, so you can hear kind of the pumps starting to wind down. That's the sound of the fans in our turbo pump slowing themselves down. So then one of the biggest things that we have to be cognizant of is when we can actually open the valve to let in air from atmosphere to our chamber. This is our turbo pump controller. You'll notice right now the screen is on. We do not open the valve on the chamber until this screen goes dark. Okay, now that the turbo pump controller has gone dark, we can go ahead and open our vent valve on our chamber to finish the job to get us back up to atmospheric pressure. In order to open the chamber, we can also go ahead and undo the knob on the top of the chamber, and this will allow us to actually open the door once we're at atmosphere, which we are still not, so we wait just a little bit longer. Okay, so now we've come up to atmosphere and I can go ahead and open the chamber. So I will go ahead and open it up and we can take a look at what we've deposited. Okay, so we started out with a clear glass slide, and now you see that shiny metal coating from the aluminum that we deposited. So now we can remove our sample and our substrate holder in the exact opposite process that we used to put it on. So you'll see now we have a very shiny microscope slide compared to the microscope slide that we started with. I can take off our sample from the substrate holder, and we wind up with a very thin metal. We anticipate about 20 nanometers in thickness, and you can't see this on the camera, but I can actually see through the 20 nanometers of aluminum that is on this sample. So this video gives you a brief overview on how we actually use our sputtering system to deposit these really thin materials. However, it doesn't take the place of the proper training in the room in person, so make sure that you get checked off by your instructor on actually using the tool. And while you can use this video for reference, obviously it never takes the place of reaching out and asking questions when you have them. Please feel free to follow up with myself. Again, I'm Dr. Kristen Roboski or Dr. Colin Inglefield, or our fabulous lab instructor, Jordan Redman. All three of us will be able to take you through properly using this tool.